Hey everybody, Marco here, and welcome to another pencil mark video. So I'm gonna be doing another one of these where I go over the puzzles I like the most in Logic Masters 2023, and these are going to be from rounds 4 and 5. I think I'm going to do round 6 in a separate video, and because it's like a 30-minute hybrid 8 puzzles which are connected round, and this one I think I'm going to do 2 puzzles from each of rounds 4 and 5 because round 5 was a huge marathon round and I just really liked round 4. In general, I thought round 4 was really cool with the genre. So this genre is POM, which is persistence of memory. The rules for persistence of memory are here on above me, I guess. It's drawing a snake that does not touch itself orthogonally or diagonally. If you know anything about like watching Sudoku videos on YouTube, it's that the snake cannot touch itself diagonally. So basically, yeah, just like I just drew a sort of an example here. It's going to connect the two circle endpoints. It cannot touch itself orthogonally or diagonally, so something like this would be a no-go because these are, yeah, touching themselves diagonally. This is orthogonal connections. That's bad. So, but something like this would be okay for a snake, for example. The thing that sets persistence of memory apart is these shaded regions here. The thing is here, first of all, every shaded region is touched. So the snake has to pass through every gray region here. And if it passes through it passes through all of them, and it has to pass through them in the same sort of path. So for example, if it goes from top to bottom here, well, not from top to bottom because it could also go from bottom to top since it's not the direction, but it has to pass through vertically. If it goes something like this, no, that's a bad example. If it goes something like, this turn here, it has to do this turn here, and by that definition, those would be connected. And that would mean that we'd have to do something like this here, and this would go down because it has to be, not touch itself diagonally or orthogonally, because these are the same shape and the same orientation. Noteworthy here, we do not count rotations or reflections in this, so this does not mean we have to do something like this because it's another V shape, size 3. Those are 2 different shapes in the context of this puzzle because they're rotated. So with further ado, there is one thing about this particular puzzle. It was the 9th puzzle in the round. Let me quickly show the round over here. Basically, this just went over through persistence of memory and a bunch of variants. The thing with a lot of persistence of memories is that border deductions were very valuable. So for example, this, just from the first one, this 3 over here, you could not enter it from below or from the right, which means you could not enter this region from below or from the right. But over here, for the toroidal persistence of memory, this grid is toroidal, which means it infinitely tiles, or another way of thinking about it is if you exit from the top, you enter a portal, and you enter it from the bottom again. So I just really like toroidal's variants. I think they're a little funky grid geometry, which is why I wanted to show this one on video. So without further ado, let's start here. Without further ado, seriously this time. So the first thing I'm going to notice here is that we need to, first of all, touch every single region, of course. And I think for this circle at the bottom right here, there's really only one direction we can go. Basically, if we go to the left, for example, we're going to end up with a bunch of crosses here because we can't have another loop segment touching the snake anywhere there because it would end up not being connected to, it would end up touching it without being connected to it, And if those X's cannot fully cover any of these regions, so this ends up covering the 1x2 here. Same thing if we end up here, it ends up blocking out both of these candidates, so this is going to end up going up here. We're still going to end up Xing out everything here, which means we need to enter this cell, so we end up turning to the right. We can end up recreating this pattern everywhere else, so this 1x3 has a line segment here, and for the 1x2s, the only other one is up here. It's going to end up going to the right here, which re-enters the grid on this side. We can X out a few cells in these positions where, it touch the snake there. Now, I'm going to say that you cannot X this out. There's got to be some sort of line segment here, because what happens if you X this out, this becomes the only snake path that you can make here, but then you have to do the same snake path over here, and it's going to go into the X with the 2x1s, I guess. So there is definitely a loop segment that enters this. We can definitely go one of two ways here. We can either exit on the right and go up, or we can go up and to the right. Both of these are still fine. Both of them will, we can't have anything going to these cells because it would sort of touch it diagonally. Because this corner, we can't have anything going in those cells either. Oh yeah, and same starting thing here. We do have to go down or to the right to have anything enter this 1x1. But we can't enter the 1x1 from the left now because this cell is blocked off. So we do have our starting deduction here for the other side. This cell here is X out. We can't X this out because that would X this cell out too. So some part of the snake definitely does touch here. And now we can't X this out because that would mean the snake would go like this. That's not going to be possible. So we do end up with this snake pattern for these V shapes. And because this is going to exit on the left, these parts are going to touch. Top cell of this size 3 V area is going to get blocked off. That would mean we can't have a snake enter this part of the V because it's going to touch itself orthogonally. So we block this off, which means we need it to enter the last part we can. And now we're going to have one more portaling line segment. This is going to go over all the way over here. So the only possible way we can exit with that is to connect to this line segment over here. That's going to X all of this out. Right, because of this 1x1, we have to continue this line segment here to the right. There's another connection. Okay, this is X'd out, so we do have X's in these spots. And this part here, we have to move a little bit over to the right and go down to connect to anything. So the only way we can do that is to move 2 over here. If we move 1, we sort of have this U shape, which we can't have in a snake. So we do the connection like this. This part here goes up and to the left. And again, no U shapes here because that would be the snake orthogonally touching itself. So we exit this one without touching the top part of the domino here. That gives us our shape on the top right, and we have our connection here. And that is the toroidal persistence of memory. We start over here on the top left. We follow the path here, going from the top to the bottom here, and then from the bottom to the top. We exit the left side of the grid and enter the right side, go through the middle, exit the left side and go enter the right side again, and then it goes down to the other circle. Very interesting path here. There's another toroidal persistence of memory that is going to show up again in the finale round later, and that was a fun one too. So I'm going to show another puzzle from this round, which I did also enjoy, but this one I had to post solve. All right, our second puzzle of the day is this final puzzle in the round. I think this was a 50-point puzzle. And yeah, this was another one I didn't fully solve during the actual competition itself, but I post-solved it and it was pretty nice. So this is an U-Bahn variant of persistence of memory. U-Bahn is a very, I think, German logic puzzle genre. I have never seen it really in a puzzle outside of Germany. So this is going to be interesting. There was an U-Bahn puzzle in the qualifier, which I sort of faulted, but ended up getting partial credit on. I'm not quite sure how that happened, but anyways, standard persistence of memory rules apply. We do need to make a snake that does not touch itself orthogonally or diagonally, connecting the two endpoints. We do have to enter the endpoints ourselves here. So this follows U-Bahn rules, where we have our shape bank here, which is endpoints, straight lines, and turns. These can be rotated, by the way. So this just says there are 7 turns, not necessarily 7 up and to the left turn segments in this column. But yeah, wherever there isn't a number, that just means we can do as many or as few as we want. So yeah, I guess our most valuable given here is the endpoints, which are not on the grid by default, but we do have to enter them ourselves. These are going to be somewhere in this row. The other big given is the 7 here, which is going to say there are 7 turns in this column. I think an odd parity is very powerful here because, I mean, if we don't have a starting point in this column, then we would need an even number of turns because this is 7 turns. There is nowhere, if there is no 8th turn, this is just going to hit the wall. So that was the starting deduction here. We need one of the starting points in this line is going to be in this 7 turn column. And I think we do have to exit this going up, because if we end up going down, we have crosses here. We only have space for one loop segment up top here, and we don't only have space for one loop segment at the bottom here, where we basically do 2 turns. So we end up going up in this spot. We're going to have segments here and here, where we either have like an S shape one way or the other to get our 2 turns and above and below. Here we still, I guess, have a degree of freedom where this segment can be of size 3, or this segment can be of size 3, but we need 2 turns on either side. This does connect to the other shape here, the other 1x3, and this cannot turn to the left and go down because that would be like this U shape we do not want in snakes. So this goes over to the right, and this part goes down to the left. It means this goes down. That also means these parts have to connect, as they do in snake. So we do have a little bit more of a segment down here. And that does give us something for this area, because every single shape in persistence of memory does need to be, so we do need 2 lines going down to touch this here. And we have to have 2 lines because the endpoint is going to be somewhere, the other endpoint is going to be somewhere in this row. So we can't have like only one thing go down and have an endpoint be here. This part here, I think, is either going to have to be a straight line or an endpoint because it can't turn. But yeah, down here we have 2 options. Either we have a straight line over here or a straight line over here. I don't think we can have a straight line over here. Well, there's this 3 clue for horizontal lines going over here, which is going to make things a little bit difficult. Real quick, I'm going to do tick marks here to say that we can't go to the right from this 1x3 area because this other 1x3 area is on the edge, and I'm also going to do a tick here. So we can't go to the right here. This is either going to be a shape like this, or a shape like this, or a shape like this. I am a teensy bit stuck here. It's been a while since I post-solved this. Let's try going through the cases with the lines here. If we do make a straight line connection here, we end up with another connection here, and we need both of these to go up to escape. That does mean we need to go through this area here, but that just breaks this whole thing wide open. So we can't have the straight line connection be here. It has to go one lower. And that takes up one of the straight line clues in the second to last row here. So we need 2 more straight lines down below. I don't think we can connect this here either, because that would give us the same sort of situation where we need 2 straight line connections in these 3 right columns, which breaks this shape here. So these do not connect, meaning these do connect. That's our second straight line. And I think the only way to get a 3rd single straight line segment is to do it in the middle, like so. Because if we do this option, we have a 4th straight line segment here. So this is going to go through the middle and up. I'm going to cross out the 3 now. We do have this segment here, which is going to connect here. That does give us our straight line in this row, meaning this thing which we said was a straight line or an endpoint is an endpoint. So there will be X's all around here. That means to connect to the rest, this needs to be a turn. And now these are diagonally adjacent, so they have to connect. We do also need a turn here to connect the bottom to the top, and that's going to make pattern here. We need our turns here and our turns here to get our 7 goal, and that pretty much finishes the left side of the grid. Now what do we have left? This is going to get X'd out, this is going to connect, and that is going to give us 3 straight line segments here, 3 horizontal lines, which means this has to be a turn and this has to be a turn in order to satisfy this clue. Yeah, 2 is also done here, and we need 2 more horizontal line segments for the 4. Yeah, there's 1, there's 2. We can't have a line segment here, so our options are 2 perpendicular horizontal lines or 2 just connected vertical lines, and obviously there's only one of those cases which works. And there we go, our U-Bahn persistence of memory. The explanation for this was quite quick, but it did require some deductions that took a while to spot. The 7 parity and the starting points, they were not as obvious as I made it seem in my post walkthrough of the solve. So that was persistence of memory. I do suggest going through this round in its entirety because persistence of memory is not a very common genre, but it does lead to some very cool deductions. I'm going to be right back, and then I'll do some puzzles from round 5. So this was round 5. We had our lunch buffet before this, so I was finally recharged a bit after eating some food. And now it was right back to the big marathon round. I think this was my worst showing because, well, I mean, the early puzzles were nice because it was just an afternoon on puzzling, basically, where it was just a whole bunch of different genres, some common, some a little bit unconventional, a little bit not seen as a lot. My big stumbling block was this part here at the bottom, where there were a lot of number-based genres which took up the majority of the high-value puzzles at the end, which is not my strong suit. So I'm going to be doing 2 of these on video because of course I will. Anyways, yeah, we start off with easy stuff like a mid loop, shaka shaka. The Dominion was fairly interesting here. Skyscrapers, but on a rectangle. Yeah, checkered Philomeno, that was very neat. I actually got this one in the last second. I just barely, I got stuck on a few puzzles at the end, so I decided to just leaf through the earlier puzzles I did, and then I noticed this checkered Philomeno was barely unfinished on one corner, so I managed to scribble in the correct solution before the end. Litz Plus was an interesting variant where some spaces could just, some areas could just be completely empty. I thought that was pretty cool. Yeah, battleships, Heiawake, Hashi, having a pretty big Hashi here. I guess, this was fairly simple. It was just a lot of scanning, but this was for the people who couldn't do the other puzzles. I guess it just took a lot of time. U-Bahn, fun. Yagit, which is sheeps and wolves. A Scrabble, which was a fairly intuitive solve. Nanro ABC box. This was a little bit weird. Neighbors, which I did manage to solve this, but it was more through casework. Round trip, funny loop puzzle, and cross the streams. And then we get to the difficult puzzles. Statue Park is just a placement puzzle, but I didn't manage to solve this in time either because there were a bunch of cases here. This one I will solve on video here because I've never seen this genre before. And it was kind of interesting here. Candles. But yeah, they also had a crop key. Partiti here, which will be the second one I'm going to show. Blackout dominoes, which they love. But I don't get some of the logic for these. They have an arrow Sudoku, which is is the meme, right? Is the championship logic puzzles or Sudoku? It's a good championship, but you open it and there's Sudoku. And Japanese sums, which was the highest point value here. This one was a fairly interesting one because there were just 4 completely unclued rows. So those were interesting to work around. But yeah, I'm going to be doing the 2 genres which I've never seen outside of this, which are candles and partiti. So let's get started with candles, shall we? Our rules here are to place some candles on empty grid spaces. Basically, candles is just marked as a rectangle. And by default, they're size 4. But if we do another candle that's orthogonally adjacent, the heights will decrease. If we do another candle here, this middle one will decrease to size 2, and this one will be size 3. So that's how the candle heights work. The clues are they refer to the sum of the candles in the surrounding 8 spaces. Bad example to choose one on the border, but for example, the 5 looks at all candles in this radius here. I'm going to mark candles with blue, and I'm going to mark the numbers on the candles in red. So, and yeah, another thing here, yeah, candles are obviously you start at size 4 and you decrease by 1 for every surrounding candle, but obviously you can't have any size 0 candles. At that point, it just melts. So here we go. We do have our 2023. A lot of the puzzles had some sort of hidden 2023. Well, not really hidden, just themed 2023. 0, of course, is going to be our starting point. We're not going to have any candles in these spots. And the 2, that means we will have a candle here with 2 orthogonally adjacent candles. This 3 here means this candle has to be a value of 1 and there can't be any stuff here, so we need 2 candles in these spots. Same thing for the other 2 clues. We need a single candle next to it and have its value reduced to 2. So it's going to have 2 orthogonally adjacent neighbors that do not see the 2. That, I think, is it for our easy starting deductions, basically. So I'm just going to circle the clues which we've completed, I guess. Or actually I'll dash them so we know we don't need to look at them. So how do we proceed from here? Right now this is a 3 height candle and this is a 2 height candle. So it is currently a value of 6 surrounding 5. The easy way to lower these would be to make another candle here, and this one, yeah, would reduce this candle to height 2. The other option, which I think is impossible, is to add another candle here to reduce this one to height 1. But now we have a candle here that's, yeah, this is currently 3. We can reduce it to 2 by adding one more candle on this side. But now we have, 2, 1, 1, 2, and reducing this to 1 we would need to make another candle that's adjacent to the 5. I think that's just going to be impossible. So we have a dash here. This is going to be a 2 candle, and we need to reduce this one to 2 by adding another candle up top. Similar thing here, I guess. We do have a 6. It's currently adjacent to a 2, a 3, and a 3, where we need to lower some of the scores a bit. We do have, for the 6 clue, right now we've got a 2 and a bunch of things that are currently 3s, and we need to lower that to 6. If we do another candle that's basically directly connected to the 6, it's sort of like a -1 and a +3 here, so it's a +2 by default. And if we connect another candle to the outside, it's a -1, sorta, if that makes sense. We can also make a +4 by connecting just a candle that's not adjacent to it. So it's a +2s, +2s, +4s, and -1s are our options for manipulating the number. And I don't think that if we make a plus anything here, then I think our number is going to become too high, and we can't reduce it enough to get to the 6. So the only way to get to 6 is to reduce these numbers twice. So we're going to end up with a 2 and a 2, and I guess a 3 here, but it doesn't really matter. So I think what we need to look at is our 5 and our 9. I mean, what that does tell us is that these numbers and these numbers, this +4 will equal that. So this area is going to be 4 more than this area. Right now, this is 3. I guess we can reduce it to 2, like so, but that's going to be the least that we're going to get in this area. I think what this does say is we need a candle in this spot. If we have a candle here, right, this is going to be a 1 and a 2 max, right? If we can't, I mean, a 1 and a 3 max if we can't have a candle in this spot. So we do have a candle over here. Yeah, right now these numbers are 2 and 4. If we have another here that's, the same, 3, 1, and 1. I mean 3, 2, and 1. Basically, these are going to sum up to a maximum of 6. And we have to keep them at this maximum, so we can't connect any candles to these. Whether we have an additional candle here, I guess, depends on the 7. And we do need an additional candle here to reduce this to 2, and then nothing else in these spots. That does give us everything we need for the 5. And yeah, that does satisfy the 9 clue too, pretty much. Since this is either going to be 2, 4, or it's going to be 1, 2, 3, I guess. All we really have here is the 7 doesn't want a 4 or a 5 as its neighbors up here. And I think it does want a 4 because this right now is 3. Yeah, so it needs a 4. If it's a 5, it's going to be, it'll be impossible to have a 2 sum in this area. So we've satisfied the 9 and we've satisfied the 7. This ending might get a little bit tricky. I mean, this 5 is going to be next to a 3. We can get 5 immediately by making another candle down below and having it be a 2 and a 3, which will X out everything here. I guess we could, this is still fine for the 7 if we just add one neighboring cell to reduce it by 1. I don't quite know though. Is there a more logical argument we can make? Yeah, actually I think so. It's just, this is the only way we can do 5. Right now this is 3. As mentioned earlier, we basically only have 3 ways we can manipulate a sum. Either we add an unattached candle, which is +4. We add a candle that's in range and attached to this candle, which is +2 net. It's +3 -1. And we connect an existing candle to another candle that's unattached, which is the net -1. So that is legitimately the only thing we can do. This 5 is going to go to the 2 and the 3. As for the 7, I think all we can say is we definitely have candles in these 2 spots. I did originally say candle here, but it's also possible for this to just be like a 4 and a 3. That could also sum up to 7. But having something like this is impossible because those are 3 max. So we definitely need those 2 candles. This 3 here is telling me that we need 1 candle with 1 unattached neighbor, basically. So we have 4 cases. It's either like this, like this, like this, or like this. That is the only way we're going to get our 3. And what is the 6 telling me? Right now, it is basically, yeah, at value 4. And it needs to add 2 more. I don't think we can do a candle in this spot because it's going to be 8 and we can't reduce it by enough. This is going to be perfect for a 6. This would give us 8 where we need to reduce, and this wouldn't change it, we would just need to reduce it by 2 by going down. I think this is actually the solution, but let me just, yeah, this would be 3, 2, 2, 2, 2, 3, which does actually give us our solution, but hang on. Yeah, basically the 6 says there are 2 connections happening here. The 7 says there is 1 connection happening here. No, wait. This 6 says there are 2 connections happening in the blue area, and the 3 says there is 1 connection happening in the red area, which means we cannot have things connected over here, and we do have a thing connected over here. And since we need 1 connection outside of the 7's area for the 7, we have this. And then we need 1 connection over these lines, but no connections over these lines, so that gives us only 1 more option for a 3. There we go. That is the logical way of doing things. And we have our numbers for our candle heights in these spots. There we go. As mentioned before, I am not very good at number placement stuff, so this is not my explaining forte, but I hope I still did a somewhat decent job here so that you could understand it. Let's go to the other number placement puzzle in this round that I want to show off, which is another genre I've never seen before this tournament, Partiti. Alright, here's the second puzzle I want to show from this round. It's Partiti. So what we have to do here is place 1 or multiple digits from 1 to 9 in each cell so that all digits sum up to the number in the top left. Same digits may not be in neighboring spaces, even diagonal. So pretty basic explanation set here with a focus on number placement and quick arithmetic. So what this rule means is that, for example, let me go back to my blue, I accidentally color picked white. So for example, for this, let's use the 7 clue here. What we can do is just place a 7 digit in this cell. What we could also do is do a 3, 4, or a 2, 5, or a 1, 6, or a 1, 2, 4, as long as the digits all sum up to the 7. So for example, the other thing is if I have a 1, 2, 4 here, I cannot do 1, 2, or 4 in the 8 cells surrounding this. So for this just breaks the 2, for example. But for the 6, what this would end up giving me is I can't do 1, 2, 3. I can't do 1, 1, 5. I can't do 2, 4, so I would have to do a 6 directly. And that's the basic idea of this puzzle. So, yeah, this was a lot of scanning, and I didn't manage to finish it on time. I got pretty far, though. So that was a little bit aggravating, but oh yeah, the other thing is there are some question mark cells here. These have an unknown sum, but basically by meta logic, we need 8 unique numbers in the surrounding cells. And this is going to be like the 9th number. We do need to place at least one number in every cell. So yeah, let's get going here. 1s and 2s, I think. We do have a single 1 and a single 2. So those are just sort of givens. I'm gonna do things we're sure about in blue, and things we might need to think a little bit more about in red. A thing I noticed while doing the example puzzle here is that pairs, especially low value pairs, are very powerful. So in this case, we only have two ways to do a 3, and they have to be one or the other here. We need a 1, 2, and a 3, or the other way around. So I'm just going to write these on the border, 1, 2, and 3. But that means we can't use any of them in the 4 or the 5. So this 5 is definitely a 5, and this 4 is definitely a 4, or like only a 4 or a 5. Now this 1, 2, 3, and 5 are blocking the 12. If we do need a 4 and an 8, I think, because if we don't have a 4, we just sort of have to, we can't sum up to 12 using only 6, 7, 8, 9. So it's a 4 and the remainder is an 8. That's why also a lot of small numbers blocking a field is valuable information there. In the same way, we somehow have to sum up to 26 with 5, 6, 7, 8, 9. 5, 6, 7, 8, 9 is, that sums up to, 35. So, and this is that minus 9. And we can only do the minus 9 by removing the 9. We can't remove the 5, 6, 7, 8, 2 of the 5, 6, 7, 8, because that would be too much. So this is 5, 6, 7, 8. I think not being able to do the 6 or the 5 or the 1 for this 6 clue, that gives us the 2, 4 here, which just ambiguates the 3 here. This is going to be, we need a bigger eraser. This is going to be the 3, and this is going to be the 1, 2. 4 and 5 blocking this means we can only do 1, 2, 3, or we can do 6. No, we can't do 6 because the 6 is here. So 1, 2, 3 is our only option for the 6, and that leaves 1, 2, 3, 4, 5, 6, 7, 8 blocked here. This means this has to be a 9, so that we just have something in this spot. This 10 over here, it's next to a 2, 3, 4, 5, 6, 7, 8. 1, 9 are the only digits we can place there, and we must. 5 is next to a 1 and a 2, means we can, this is directly a 5. This 10 is next to a 1, 2, 4, 5, but we still need to sum up to this with 2 digits because it is 10 and our digits are 1 to 9, so this is going to be a 3, 7. The 14 here is either going to be, it's 1, 2, 3, and 4 are blocked here, so it's either going to be a 5, 9, or a 6, 8. I guess we can mark down those candidates. Same here for the 10. Those candidates will be 2 and 8, or 4 and 6. Something here with the 5. The 2 is blocked, so there are only 2 ways to make 5. It's going to be 1, 4, or 5. We can draw them on the border here. And having both the 1 and the 2 blocked for the 6 means we do go to the 6 by default. The 7 here, well, no, we can't. We still have options for that. We can't do anything with a 2, obviously, or a 6, or a 5, or a 1. Yeah, 1 and 2 being blocked is huge, but we still have the option to do 3, 4, or we have the option to do 7 directly. Those are our only 2 options, though. Now we are starting to get into a little bit of a dicey area where we have multiple options for each area. These are the 2 options for 4. Both of them work. No, they don't, because there's a 4 here. So this is going to be a 1, 3. For the 6 here, that 1, 3, and 5 are blocked. We are either going to have 2, 4, or 6, but look here, 2, 4, that's going to block both the 4 and the 2 in this 10. So we need to go to the 6 directly, which is going to block this 6. So we can erase these and go for the 2, 8. There's some interesting cascading logic there. And now an interesting thought is in a 2 by 2, every single number can only appear once. So we only have like a sum of 45 basically. This is going to be, 27 already. It's going to be 37 in total. So an 8 sum is going to be missing from this area. Since we have a 1 and a 3, I'm not quite sure if this logic holds up actually. And we also have a 6, so it can't be like a 2 and a 6 missing. So there is no 8 in this area. Right, and the remaining numbers actually form groups of 9. So I think we've got a pretty interesting pattern here. We've got 9, we've got 2, 7, and we've also got 4, 5. 2 of these are going to go to one side, while one of these will go to the other side to make 9 and 18, which is 2 times 9. So we have 3 groups which all sum up to 9 here. That is a pretty interesting pattern there. I'm wondering if it's possible to deduce the 13, but it might be a little bit too tricky. Let's see what we can do elsewhere first. This 12, the options to go here are 1, 2, 4, 8, 9. 1, 2, 4, 8, 9. 4, 8 is of course, oh, and if there is a 1, 4 in this spot for the 5, the candidates are 2, 8, 9, and it's impossible to make a 12 out of those candidates. So I think that does disambiguate this. We need a 5 in this spot, and we need a 1, 4 in this spot. 1 and 2 here does give us a 6 in this spot, but the corner here is a little bit useless right now. So what else do we have? I guess I'll write down our candidates. 1, 2, 4, 8, 9 was it? So the 9 pairing up with a 1, 2 is fine. The 8 pairing up with a 4 is fine. It's just one of those two options, really. We need an 8 or a 9 because the numbers without it will be too small. And yeah, that's the only way we form the remainders. 1, 2, 9 will block the 9 off pretty heavily, I think, because if this is 1, 2, 9, 1, 2, and 3 are blocked, as well as 9 and 5. So we can't directly go for the 9, and our lowest 2-digit sum is 4, 6, which is 10. So we're going to have to go for 4 and 8 here. Yeah, this is obviously 1, 2, or 3. For the 9, 1 and 2 are unblocked. 3, 4, 5 are all blocked. So our candidates here are 1, 2, 6, and 9, and it is those two options specifically. 1, 2, 6, or 9, because 3, 4, 5, 7, 8 are all blocked. So we either sum up these 3 digits to make 9, or we go for the 9 directly. I think this is going to narrow down the 8 by a lot. If we choose the 9 here, we go for the 6, 8 here. So either way, this cannot be a 6. It's tough here to get the upper corner. Quickly, this is splitting the puzzle in two, but I'll just quickly do this here. We had our 3, 4, and 7 options here, but now with the 4 in this spot, we can just write the 7 out. Our candidates for 16 are 1, 3, 4, 5, 8, 9, so still a lot of options to go in this spot. Well, let's take a look back up here. Our candidates for this 13 are 1, 2, 3, 4, 5, 6, 7, and 9. So either we have 7 and a remainder of 6, or 9 and a remainder of 4. That means we definitely do have 1, 3, and then either 2, 7, or 9. We can write it out like this. And yeah, that gives us, that makes this 1 impossible to place here. So this is going to be straight up 9, and that gives us 2, 7 in this spot. That's pretty interesting. 1, 2, 3, 4. Our options here are 5, 6. It's going to be probably one of these two to make the question mark cell. 9 leads this to go to 6, 8. I want to undo, not cut. The 6, 8 being there, this 8, we can't go to 8 directly. And we also can't, well, that means we do need at least a 1, 2, or a 3. So this is going to be a 3. So we need a 1, 2. Yeah, our candidates are 1, 2, 4, 5. Yeah, those are our only candidates. We need a 5 because the rest sums up to 7, and then we go for 1, 2 because that sums up to 3. And there we have the top left corner of our Partiti. All that's left to do is to figure out how the heck this bottom row is going to resolve. This is going to be very, very tough. The 16 could resolve through, if we have the 9, we'd end up having to get a rest of 7, which is 4 and 3. If we start with an 8, we need a rest of 8, which is going to be 5 or 3, or 4, 1, 3. And without either, then we would have a remainder of 13. So we need one of these options. We need an 8 or a 9. Oh wait, why do I have an 8 here? There's an 8 in this spot. I just didn't scan properly. So we definitely need a 9. And then we end up making our remainder of 7 with the 3 and the 4. That's our only option to do that. So that gives us our 3. That's not a 3. 4, 7. I'm getting confused with my words. 3, 4, 9. That pushes both the 4, 5 pair and the 9 pair over to the left side, over to the right side. And we have our 2, 7 pair go to the left. Now this 13 should be resolvable. Our candidates are 2, 6, 7, 8 of course is impossible since we'd have a remainder of 5, and then this sums up to 15, so we need the 6, 7. And the only number which isn't in the surrounding ones is 2 here. That's that. And our candidates for this 13 are 1, 5, 8. So it's 5, 8. And that gives us our last number here. 1, 2, 3, 4, 5, 6, 8, 9. So this is going to be 7. And that is our grid filled in finally. This was a very, very scanning heavy puzzle here, and I don't think I can solve this puzzle here. Even on resolve, I probably can't solve it in the part time needed for the actual competition itself. But still, this was a pretty interesting addition heavy puzzle type that I don't really see around a lot, and I hope seeing it a little I can guess that you probably haven't seen this a lot either, and maybe seeing this a little helped expose some new ways of thinking about number logic or something like that. Anyways, I'll be back with a bunch more videos. I think video 3 will be about round 6, which was a 30-minute round of 8 interconnected puzzles with a cipher. And rounds 7 and 8 were interesting too, so I'll have a 4th video on those. And maybe, just maybe, a 5th video where I go over all the finale puzzles. So that's been it for me for now. Bye bye.